This is a multiple choice question about the convergence warning that sometimes pops up when you're training a support vector machine SVM model using the sklearn library. I'm testing your understanding of what this warning means and how you might handle it. That's absolutely right. The warning says the optimization process didn't finish, so you probably didn't get the very best possible solution, but it might still be pretty good. Nope. Increasing max_iter which stands for maximum iterations, often helps, giving the algorithm more time, but it's not a magic bullet. There might be other issues affecting convergence, and simply increasing the number of iterations might not solve those. Plus, you'll waste a lot of computation time if you increase it too much. This is a great idea. The "C" parameter controls the balance between maximizing the margin and minimizing errors. The wrong "C" value can cause the optimization to slow down or even fail to converge. The choice of kernel function also matters. Experimenting with these settings can often get you better results. This is incorrect. Although poor data quality, like too many dimensions or some weird data points, can make convergence more difficult, the warning itself doesn't automatically mean that your data is the problem. The model might still be useful, depending on its performance. We need to investigate further. This instruction means there's likely more than one correct choice. I want you to pick each of the statements that correctly describes the convergence warning and how to approach it. I'm focusing on how to handle the convergence warning you get when training a support vector machine, SVM, using the popular Python library, scikit-learn. This warning pops up when the SVM's optimization algorithm doesn't quite reach its goal within the allowed number of steps. We'll investigate what that means and how to fix it. This is a multiple-choice quiz to test your understanding of the warning and possible solutions. Imagine you're training your SVM model, and suddenly, this warning pops up. It essentially says the model's training process didn't completely finish, indicating a potential problem that we need to address to get the best results. I believe adjusting certain settings within your SVM model, like the "C" parameter, which controls the balance between maximizing the margin and minimizing errors, or the type of kernel you use, could solve the problem. Think of it like tweaking the knobs on a complex machine. Fine-tuning those hyperparameters can make the training run smoothly. This statement is incorrect. The warning doesn't automatically mean your data is bad. The issue might be with the optimization process, not the data itself. The model might still be useful after fixing the training process. This is false. Increasing the maximum number of iterations, max_iter, often helps, but it's not a guaranteed fix. The underlying problem could be something else entirely. This is true. The warning directly implies that your model did not reach the absolute best solution due to time constraints, but you can still get useful results. Let's dive into troubleshooting the convergence warning you get when training support vector machines, SVMs, using the popular scikit-learn library in Python. This warning, specifically when using the liblinear solver, tells us that the SVM's optimization process didn't quite reach its goal within the allowed number of steps. Think of it like this. Imagine you're trying to find the lowest point in a valley. The algorithm is taking steps downhill, but it ran out of time before reaching the very bottom. We need to figure out why it stopped short and what we can do about it. The liblinear solver is one of the options available in scikit-learn's SVM implementation. The error message itself tells us the solver, the computational engine that finds the best SVM model parameters, couldn't complete its job within a set limit. It means the optimization algorithm didn't find a solution that meets the convergence criteria within a specified number of iterations. It does not directly mean your data is bad. It simply means the algorithm didn't have enough time or resources to complete its search for the best solution. The question presents 4 statements, and we must analyze each to determine which accurately describe the implications and potential solutions for the convergence warning. This is a critical analysis of the consequences of the warning as well as understanding how you can mitigate such problems in future. This is likely true. Failing to converge means the algorithm didn't find the absolute best solution. However, remember, the solution might still be pretty good for practical purposes. It's just not mathematically perfect. I'd say this is false. Increasing max_iter, the maximum number of iterations, gives the algorithm more time, but it doesn't fix underlying problems. Think of it as giving the valley searching person more time to walk. They might get closer to the bottom, but they might still be stopped by some other obstacle. There could be other issues like poorly chosen parameters that aren't solved by just giving more time. This is absolutely true. The C hyperparameter controls the trade-off between fitting the data perfectly and keeping the decision boundary simple, while the kernel determines how data points relate to each other. Improper settings here can make convergence difficult. It is like adjusting the person's step size or providing them with a better map of the valley. The C parameter regularizes the model, balancing the fit to the training data against the simplicity of the decision boundary. The kernel dictates how the algorithm maps the data into higher dimensions to find a separating hyperplane. Experimenting with different values and types can significantly impact convergence behavior. I see a convergence warning, and that's a common issue when training support vector machines, SVMs. It essentially means the algorithm didn't quite reach its goal within the set number of tries. We need to figure out why and how to fix it. Think of it like trying to reach the top of a hill. The algorithm might have gotten stuck on a lower slope instead of reaching the peak. The core problem is this pesky convergence warning popping up while training an SVM. It tells us the algorithm used to find the best model parameters didn't finish its job fully. Let's diagnose it, identify the root cause, and learn how to deal with it. Here we have several possible reasons why this warning might show up, and some solutions to consider. It is like a multiple-choice quiz to test our understanding of the problem. Increasing the maximum number of iterations, MAXITER, might fix the warning by giving the algorithm more time to converge. That is, it gives the algorithm more chances to find a better solution. However, it isn't a magic bullet. It's not guaranteed to work. Because the root of the problem could be something else entirely. It's like adding more fuel to a car. If the real problem is a flat tire, you'll waste fuel and not fix the problem. Tuning the hyperparameters, such as C, the regularization parameter, which controls the balance between maximizing the margin and minimizing classification errors, or the kernel type, is a smart move. The C parameter helps control how much the model tolerates misclassifications, while the kernel type determines the decision boundary shape. A better choice here can significantly improve convergence. It's like adjusting the tools to suit the task. The right settings might enable a much smoother process. I think the warning strongly suggests the model didn't reach the absolute best solution possible. It got stuck. Remember that the algorithm is searching for the optimal solution, and if the algorithm stops before finding it, it didn't quite succeed. However, it's important to note that even a suboptimal solution can still be a reasonably good model. I need to understand what this warning means in the context of SVM training and explore ways to resolve this warning. This involves recalling the facts about this warning, grasping the meaning, and applying the right solution. This statement is incorrect. Although problematic data, like many irrelevant features, outliers, etc., can contribute to this problem, the warning itself doesn't necessarily mean there's a problem with your data. The model could still be quite useful. It just couldn't finish its job due to the solver's limitations. I'm tackling a common issue in support vector machine, SVM, training, the convergence warning. This warning pops up when the algorithm used to train the SVM model doesn't find the best solution within a set number of tries, iterations. Think of it like searching for the lowest point in a valley. The algorithm might stop before reaching the very bottom. This sets the stage. You're using a popular machine learning library, sklearn, and its SVM function with the liblinear solver, which is a specific optimization technique. The warning explicitly states that the solver ran out of time before finding its best solution. It can adjust some settings, hyperparameters, to potentially help the algorithm find the best solution more easily. Think of C as a dial that controls how much the model cares about correctly classifying every single data point versus having a clean margin of separation between classes. The kernel defines how the model transforms the data, altering the complexity of the solution space. I might need to tweak those settings to improve convergence. It's tempting to blame the data, but that's not necessarily the case. While poor data quality, like too many features or an uneven distribution of classes, can make convergence harder, the warning itself doesn't confirm that the data is at fault. The model might still be useful after I address the convergence issue. It can give the algorithm more time to find the solution by increasing max_iter, the maximum number of iterations allowed, but that's not a guaranteed fix. The underlying problem might lie elsewhere, like in the model's settings or in the data itself. Simply increasing the iteration count might also lead to unnecessary computation time. The warning explicitly states the model did not converge, therefore, it probably didn't find the absolute best solution possible. However, that doesn't mean the results are completely useless. It might still be a pretty good model. Based on my understanding, I can determine which of the above statements are true and explain why. This is where we bring everything together to test my knowledge and problem-solving skills. I see that you're asking about increasing the max_iter parameter to fix the convergence warning. While increasing the maximum number of iterations often helps the algorithm find a better solution, it's not a guaranteed fix. The problem might be something else entirely, like a poorly chosen regularization parameter or a fundamentally unsuitable kernel. Think of it like this. Giving someone more time to complete a task doesn't always mean they'll succeed if they lack the right tools or skills. The convergence warning means the support vector machine, SVM, algorithm didn't reach an optimal solution within the given number of iterations. It's like searching for the lowest point in a valley. If you stop looking before you reach the bottom, you have a suboptimal solution. This doesn't mean the model is completely useless, but its accuracy may not be as good as it could be. I totally agree that tuning hyperparameters like "C", the regularization parameter, and the kernel type can dramatically improve convergence. The "C" parameter controls the balance between correctly classifying points and maximizing the margin. The kernel defines how your model handles high-dimensional data. It's like adjusting the knobs and dials on a machine to get the best performance. A poor choice of either can prevent the algorithm from converging effectively. You're wondering if the warning automatically means your data is bad. Not exactly. While data issues like many features or imbalanced classes can contribute to slower convergence, the warning itself primarily indicates a training process problem. The model might still be useful after addressing the convergence issue. This is the context that sets up your entire problem. Understanding the implications of a convergence warning when training a support vector machine model using the liblinear solver in scikit-learn.